Quiz 6. In the UK, gasoline is about 1.19 British pounds per liter. Determine this cost in US dollars for 1 gallon of gasoline. Well, we have 1.19 British pounds per liter. Well, let's first determine how many British pounds this would be for a gallon. And a gallon of gasoline, let's see, there are 3.78541 liters in 1 gallon. So now we know what the cost would be in British pounds per gallon. And so we have some conversions here between the pound and the euro and the dollar. So it turns out that for one British pound, we're going to have, let's see, 1.38424 euros. So the British pound will drop out. And now we have the amount of euros per gallon. And now we have to multiply this by 1.08 because there's $1.08 for every euro. And then the euros would drop out. And so now we'll get dollars per gallon. So let's just calculate that out real quick. We're going to get 1.19 multiplied by 3.78541 and multiply that by 1.38, what is that, 424? And then multiply that by 1.08. And we're going to get $6.73. So 6.73 per gallon. 6.73 per gallon. A homeowner determines 75% of their home requires new carpeting, and carpet's going to cost $32.50 a square yard. So how much will it cost? Okay, well, not the whole home, but only 75%, so 0.75. And so that much of the total square footage, and it was a 2,400 square foot home. And that's about an average size home. So 2,400 square foot home, 3/4 of it gets carpet. And carpet now, oh yeah, carpet costs per square yard. You know, some places they'll charge you by the square foot. Some stores, they'll charge by the square foot because it turns out that there's 9 square feet in a square yard, and so they charge carpet by the square foot because it looks cheaper. And so let's see, we have to convert this to yards. So there are 3 feet in 1 yard. And we have to have feet squared, so we're going to have to square that quantity. See, 9 square feet in 1 square yard. And so now it's just adding in the money. And so we're multiplying it by the money, $32.50 per square yard. Good. And so now we're just left to calculate it out. So 0.75 times 2,400 divided by 3, and then divided by 3 again, and multiplied by $32.50. And you get $6,500. So $6,500 is the total cost. Again, the feet drop out, the square yards drop out, and we're left with dollars. $6,500. I was on Facebook and I saw this roadmap that goes through the whole U.S. and you get to go through all the different states in the lower continental U.S. and you get to go through all these landmarks. I just thought that was a great idea. So 14,000 mile trip. You know, you just hop on, you travel all around the U.S. And so I wanted to see how much it would cost for gas. And so if you take a car, you're going to go what 14,000 miles, and your car is getting 30 miles per gallon. So we have 30 miles per gallon. And gasoline is $2.35 a gallon. So for each gallon, gasoline is 2.35, and we can see how much the total cost is. So the miles and then the gallons, and so 14,000 divided by 30 and multiply by 2.35, and that's about $10.97. So $1097 if I used my car. Now if I take the same trip, the 14,000 miles, say I'm going to use my my motorhome. Say I use my motorhome, 14,000 mile, and my motorhome gets 12 miles per gallon. So 12 miles for every gallon. And then in cost of gasoline is $2.35 for every gallon. So I have 14,000 miles, divided that by, let's see, 12, and multiply it by 235. And I get 27.42 almost. 27.42. So it's going to cost $2,742 for gas approximately, or if I take the motorhome, and $10.97. That's this one, $10.97 for the car. A cylinder and a sphere have the same radius and volume, and the volume says it's 36 pi cubic centimeters. It says determine the height of the cylinder. So the cylinder and sphere have the same radius and the same volume. So the volume of a cylinder then has to be equal to the volume of the sphere. And the volume of the cylinder is going to be pi times r squared times the height of the cylinder. And the volume of the sphere is 4/3 pi r cubed. Well, the pi's drop out, and the r squared will drop out two of those, so we'll be just left with an r on this side. And the height of the cylinder then would be 4/3 r. So if I knew what the radius is, I can tell you the height of that cylinder, because that height of the cylinder is going to be 4/3 times r. So I just need to find out what the radius of that cylinder is. But I know what the volume of the sphere is. The volume of the sphere is 36 pi. And that is 4/3 pi r cubed. That's the volume of a sphere. 36 pi, and the formula is 4/3 pi r cubed. Notice that pi is going to drop out. And let's see. Well, it was 36 pi cubic centimeters, so I should probably include my units here. 36 pi cubic centimeters. Well, the pi still is going to drop out. So then I have, I'm going to have to multiply both sides by 3 and divide both sides by 4. Because if I multiply by 3/4 on this side, that cancels this out, and multiply by 3/4 on this side. So that's going to be 3 times 36 cubic centimeters divided by 4 is equal to r cubed. Well, then we have to take the cube root, right? So we take the cube root of that. And so we plug that into our calculator, and we get 3 times 36 divided by 4, and we get 27. Well, we don't need to find the cube root of 27. We know what that is. 3 times 3 is 9, and 9 times 3 is 27. So the cube root of 27 is 3. R is equal to 3. And then notice you take the cube root of the cubic centimeters, so that's also going to be just centimeters. So R is 3 centimeters. So we have 4 over 3 times 3 centimeters. And then we cancel out the 3, and we're just going to get 4 centimeters. That is the height of the cylinder. So now we have 12 inches of snow. It's equivalent to 1 inch of rain. Okay. 6 inches of snow fall on a roof. What is the weight of the snow on the roof? Well, 12 inches of snow is equivalent to 1 inch of rain. So we have 6 inches of snow. And 12 inches of snow is equivalent to 1 inch, and I'm just going to say R. Well, I won't say R. 1 inch of rain. So 6 inches of snow, I put an S there for snow, and we have 12 inches of snow and 1 inch of rain. Okay, so we have an inch of rain basically on the roof for every 12 inches of snow. So if we have 6 inches of snow, we have 1/2 of an inch of rain. So the inches of snow will drop out. So now we're just talking about the amount of rainwater, because 1 cubic feet of rainwater is about 62.5 pounds. So we need to get how much volume of rain is on the roof. So if you have a roof, and let's see if I can draw this right. We have so many inches of snow on this roof, and then let's see. Okay, so we had 6 inches of snow, which is 1/2 of an inch of rain. So this side here would be 1/2 of an inch of rain. And we'll get that by doing this math here. And then we have 1/2 of an inch of rain, and we have to multiply it by this length and this width. So let's convert this into feet. And so we have 12 inches in 1 foot. So now we have the feet of rain. This is the feet of the thickness of the rain. And so now we have to multiply that by the width and the height. So we have 40 feet. And we multiply that by 50 feet. So this gives us the total volume of how much rainwater equivalent is being held on that roof. So this is going to be, the inches are going to drop out, and the feet is going to be feet cubed. And so we have, for every 1 cubic feet of rain, we're going to have, it looks like 62.5 pounds of weight. Okay, 62.5 pounds of weight. So let's just calculate it. So we have 6 inches of snow, and we're going to divide that by 12 because there's 12 inches of snow in every 1 inch of rain. And now we're going to convert this inches into feet, so divide by 12. And then now we have the thickness. We have this thickness in feet, and we're going to multiply this in feet and this in feet, because the volume is a length times a width times a height. And so we have the thickness here, and then we're going to have the height, and then the length and the width of the roof. And so we multiply that by 40, and we're going to multiply that by 50, and then we're going to multiply that by 62.5. And I get 5208 pounds. So 5208 pounds. And I should have looked a little bit more carefully, because they didn't want it in pounds, they wanted it in metric tons. Well, there are 2.2 pounds per kilogram, and there's So there's 2.2 pounds per kilogram, and there are 1,000 kilograms in 1 metric ton. So 1 metric ton has 1,000 kilograms. So we're going to have 5208 divided by 2.2 pounds, and then we have to divide that by 1,000, and we're going to get 2.37 or 2.36 or so metric, 2.367, so 2.37 metric ton. 2.37 metric ton. So 2.36 metric ton. That's a good approximation. And 2.36 metric tons is a good approximation because we didn't really put in the full number here. So the problems require you to know all the conversions. So in order for you to do really well, you needed to make sure that you knew all of the constants that I have given you. So keep practicing, and we'll get started with the next lesson.